So first of all, I already introduced myself. I'm Ismail Khoffi, CTO and co-founder of Celestia Labs. Before I joined Celestia, I actually worked in Switzerland, not too far away from here, in Lausanne at the mentioned EPFL, the Decentralized and Distributed Systems Labs. That's where my crypto journey started. And afterwards, outside of academia, I was part of the Tendermint team who launched the Cosmos Hub, the first proof of stake network built on the Cosmos SDK. So modularity was mentioned a lot, and I think people already have an idea what it is. I think I'll go a lot more into detail, but still try to keep it short so we can have lunch. So all chains that when the first, so to say, blockchain launched, it was Bitcoin and later Ethereum, they are monolithic in the sense that both of them do everything a chain does. They do run the business logic as well as they have their own consensus. So in Bitcoin, it was Nakamoto consensus or proof of work, longest chain rule. And then there's actually also a small scripting language with which you can script Bitcoin. It's called Bitcoin script actually. It's a bit limited. And then Ethereum came along and said, well, Bitcoin has payments as an application. What if the application is actually be a world computer, have people deploy arbitrary programs, so-called smart contracts, in this world computer. But that's the business logic of Ethereum. You can run anything. And then the consensus is slightly different. I don't want to go too much into detail. The takeaway here is these chains do everything, business logic and execution and consensus. My co-founder Mustafa came along and introduced, also, by the way, coming out of Ethereum research, the ideas are very, the motivation is of all the teams that were on the panel, I think are very similar. All of us wanted to scale Ethereum. And then decided one way or the other, there's a better way to actually scale this. And so my co-founder introduced Lazy Ledger coming out of Ethereum research, where there was this data availability problem in between shards, where Ethereum was still trying to do execution sharding. And Mustafa had this idea as why don't we actually just build a chain that doesn't do execution and just does data availability, and these smart contracts or the business logic runs somewhere else, on a different chain. And that's basically the first step to modular blockchains. As mentioned before, the key idea here is to decouple execution from consensus, and then have the execution happen in a different chain, often called the rollup chain. So what are the things, I don't know if everyone knows these words, and they were mentioned also on the panel, but what are these things? Execution, settlement, consensus, and data availability. So consensus is literally just transaction ordering, or ordering of arbitrary messages, right? These messages, if you take the analogy of the book, it's ordering into words and pages. But these words and pages aren't parsed, they aren't understood, they're arbitrary, right? They're not read, so to say. They're just ordered and published. And the publishing is guaranteed by what's called a data availability layer. Here, the key is that these ordered messages, there's a way to verify that they have been published. So you can know that you can actually go and read the words in the book. And you can be sure they have been widely published, right? Everyone has access to them. So in traditional blockchains, the only way, if you wanted to know if all the words have been published or all the messages have been published, the only way to know this is you had to basically go download them on the network, which is also something that doesn't scale, because if we speak about massive books or massive blocks, massive terabyte blocks or gigabyte blocks, this won't work because it's just not feasible. So similarly, in this research that was done for how to scale Ethereum, my co-founder Mustafa with Vitalik came up, when Alberto Sonio came up with this method called data availability sampling, where you can, instead of having, if you want to verify that the data was published, instead of having to download all the data, here you can just download a tiny portion. You sample like a few words, so to say, but through very simple math. It's not like ZK, it's very established stuff that like CD-ROMs used in the 80s and so on. With very simple math, you get the guarantee that with these few words, you know the whole book has been published and has been widely published in the network. So the execution layer is what is the most interesting. Like, this is where the business logic happens, right? We were talking about like state, and I think the most easy thing for everyone to understand is you have account balances, you have payments, like transactions are payments, and then you update the account balances. That's like the execution, right? Like you have a previous state, you have a transaction, you change the account balances. But state can be anything, right? Like business logic depends on your business case, depends on your application. If you followed along also on the panel, there's essentially two ways that guarantees the validity of these state transitions, right? As I said, Celestia, previously called Modular, but like Celestia, does not do any execution. It doesn't guarantee that these messages, these arbitrary messages, had been ordered and published. It doesn't guarantee that they are actually valid state transitions. And there's two approaches on how to guarantee that these state transitions are all valid. One is so-called fraud or fault proofs, or often used in we're often called like optimistic rollups, where you assume that in most cases there is no invalid state transition, but if there is an invalid state transition, any full node can go and publish like a short proof and give it to anyone in the network, and make sure that everyone noticed, oh, there was an invalid state transition, let's ignore that block, or let's resort to governance mechanisms to fix the chain, so to say. And for validity proofs, you have a mathematical proof that guarantees you that the computation was actually done correctly. They're often called like ZK proofs or ZK rollups. And zero knowledge tech is actually like also has a privacy component, but here the more important part is not that you don't have to reveal any information. The more important part is that you can guarantee that the computation was correctly. But the privacy tech here is actually also interesting and important. I think will also become more relevant, but that's a different story. It's worth to mention that Celestia does not doesn't enforce you to use one or the other. It basically supports both these kind of rollups. Like Celestia is like Switzerland, basically very neutral. You can do whatever you want. So what is a settlement layer? Basically, a settlement layer bridges between different execution environments or different execution layers, right? Ethereum was mentioned a lot of times. Ethereum is a perfect use case. You have several rollups. You can use a settlement contract to bridge between these rollups, or bring your assets back to the layer one, or go to another rollup. Fine. So what is a modular blockchain? A modular blockchain, like our definition of that is, it's a chain that outsources at least one of these components that I explained, right? Like it doesn't handle that themselves. But either execution, settlement, consensus, data availability is outsourced. Okay, very technical, and why would you care? Why is this relevant? I think it's worth mentioning also to like enterprises that understand Web 2, that this is like very similar to the evolution that has gone through the web, like traditional web essentially, right? In the early web, when you wanted to deploy an application or a website, you had to deploy your own physical server. very similar in the early days of crypto, you had to deploy your own chain. You had to fork like Bitcoin to launch Namecoin or whatever, right? Or Ethereum is also its own chain and so on and so forth. In the developing web, you had these hosting providers, right? You had GeoCities and so on and so forth, and it made it much easier to launch your own application. But you had to use, or you were limited by the choices these hosting providers made for you, right? Like you had to use PHP or Perl or whatever to develop your application. Similarly, these like smart contract blockchains allowed you to develop your decentralized application much quicker, but you were tied to the choices and that these smart contract platforms made for you. It's like you had to use Solidity, you had to adhere to their fork choice rules, and so on and so forth. In the modern web today, like websites run on virtual machines that like share physical machines, right? Like Google Cloud probably knows best, but this is how the world works today. And in modern crypto, this is also what we're seeing, and it's already happening with Celestia, but also like Ethereum is pivoting in that direction. Decentralized applications run on application-specific chains that share the consensus layer. That's the analogy. Celestia is the first modular blockchain network. We coined the term modularity. It's live, it does data availability sampling, and the main takeaway is that decouples consensus from execution. So why is this relevant to you? It actually brings scalability. The architecture itself is removing the main bottleneck from this like world computer model, where every node has to run every program essentially, or every smart contract. Literally, the rollups are dedicated compute for a specific use case. There's also more to it, like more light nodes mean more secure block space, but I don't want to dive into that. Oh, this slide is, actually there it is quite visible. It brings cost savings compared to like Ethereum, or compared to if you really just care about cost and not care about decentralization, you would just use a central server. It's much cheaper. But if you care about decentralization and don't want like a permissioned, either a cloud provider or a permissioned data availability committee that is controlled by a single entity, but want to use like a permissionless network and a proof of stake network, then Celestia does that, but still saves you a lot of cost. Like even with the last Ethereum update, it's like 10 times cheaper. And it gives you a lot more choices, right? Like these layers that I talked about, you can match them like Lego pieces together. Like that unlocks new applications, it unlocks new deployment scenarios, and I think one specific mode of operation that wasn't possible before, where you can have like the freedom of a new layer one without like the massive overhead of like launching a new layer one, is the like so-called sovereign rollups, where you use a DA layer for consensus data availability, but you don't settle on a specific settlement layer. Like this is, as mentioned on the panel, this is like particularly relevant for chains that don't want like the highest security of Ethereum for a specific settlement layer, or do not need to be part of a specific ecosystem, but want their community to be as like sovereign as possible. So key benefits for enterprises. Luckily, this was also mentioned in the first presentation to some extent. Enterprises can stay focused mainly on their like product and their business logic. They don't need to deploy the underlying consensus networks themselves, right? There's like two ways this can work. Either you own the infrastructure yourself, which can also mean you have a centralized sequencer, but because that centralized sequencer publishes data to Celestia, this centralized sequencer still can't do anything malicious besides maybe shut down the service, right? If that might be actually a valid use case for enterprises, where they are in control. They are like for regulatory reasons or something, they need to be somewhat in control of the infrastructure, of the business logic, but still want full transparency via a third party that is like incredibly neutral and decentralized. Alternatively, you can use something like Gelato, which is like a rollup as a service provider, where you can think of it as like you click a button, you choose a few parameters, you click a button, and then you get like a chain deployed. But like additionally, you get all the tooling on top that would be needed for the chain to actually work, right? As I mentioned, like we hear this Gelato. There's actually a great zoo of like these rollups as service providers. So you're even not tied to one specific. Like with Celestia, you can choose whatever you want. Yeah, cost savings and scalability. I think that wasn't mentioned by everyone to a large extent. So what is next for Celestia? We want to achieve Web2 scale for blockchains. We're still not there. We're getting there with this like design and architecture. The architecture is there, but like we still aren't there in terms of like throughput. We want like abundant block space and throughput. So our goal is to have the gigabyte blocks. Right? Like if you look at like what blockchains do today, there's like 1 megabyte or something like that. Even Ethereum with like the latest upgrade, I'm not sure. I think it's like for like 2 megabytes. I think to actually serve the whole world or like serve, if you want mass adoption, there will be a larger need for block space. And if we actually want to like serve all that, we need much larger blocks. And like Celestia's goal is to have at least a gigabyte blocks. We want full trust minimization. So this like verifiability idea doesn't mean anything if you make it hard for people to like actually verify the chain, or you have like only centralized infrastructure in like wallets and everything just uses centralized infrastructure. So what we want is we want everyone to run light node. Everyone actually verify the chain without having like it's like super simple. You run it on your phone, you run it in your browser. You wouldn't like necessarily notice, but it's a huge difference from using a centralized provider to running your own node. So we like our goalpost is like 1 billion light nodes. And yeah, we believe there will be a lot of more rollups, and we want to serve all those. 1 million rollup. I don't think that number is like exaggerated. I think we'll see it over the next 3 years. Thank you. That's it.